Good morning, student of class 10th. We are doing real numbers. Today we will do decimal expansion. We have studied in class 9th also. Decimal expansions are of two types. First is terminating and second is non-terminating. Again, non-terminating are of two types. First is recurring or repeating. Recurring or repeating. Second is non-recurring. Or non-repeating. Terminating or non-recurring. Both are the decimal expansions of rational numbers. And only non-recurring or non-repeating is your irrational. Clear? Now according to your theorem, if a number is in the form of p by q, where q is not equal to 0, then the prime factors of q, if is in the form of 2 to the power m into 5 to the power n form, where m and n are non-negative integers. So this type of decimal expansion is terminating. If a number is in the form of p by q where q is not equal to 0, means it is rational number. And if rational numbers denominator q's prime factors in the form of 2 to the power m into 5 to the power n, where m and n are non-negative integers, means both power will be positive. So in that case, this decimal expansion will be terminating. Terminating. Decimal expansion. Second, non-terminating. Opposite case of this, same case, if a rational number p by q where q is not equal to 0 and prime factors of q is not equal to 2 to the power m into 5 to the power n, then it is non-terminating. So simple, you have to check only prime factors of denominator. If prime factors is in the form of 2 to the power m into 5 to the power n, then we will say this is terminating decimal expansion. And if prime factors of denominator is not equal to 2 to the power m into 5 to the power n form, then we will say non-terminating. Clear? Now we will do some questions of exercise. Exercise 1.4. Saying without actually performing the long division, state whether the following rational numbers will have terminating decimal expansion or non-terminating, repeating decimal expansion. So I am taking here one example. Question number 1, exercise 1.4, question number 1. 17/8. Check whether terminating decimal or non-terminating. Decimal, terminating or non-terminating decimal expansion. First part is 17 upon 8. So since denominator 8 is 2 into 2 into 2, so 2 to the power m form, so it is therefore terminating decimal expansion. Another part, it is B part. Next one is C 5 29 upon, it was first 5 29 upon 343. So since denominator 343 is the cube of 7, 7 into 7 into 7, so q is not equal to in the form of 2 to the power m into 5 to the power n, therefore non-terminating decimal expansion. Clear? So this way you will do remaining parts. Clear? What is terminating and non-terminating? First we will do prime factors of denominator, and if this factor in the form of 2 to the power m into 5 to the power n or 2 to the power m or 5 to the power n, then we will say it is terminating. And here prime factors of denominator is not in the form of 2 into 2 to the power m into 5 to the power n, because here 7 available. That's why this is non-terminating decimal expansion. Thank you, class.